as promised, more examples for lesson 9.2. So again, with these examples, I really want you to pause the video, try them out on your own, and then check your work. Don't just wait for the answers, all right? Try and see what you can do. That way, if you have questions, you know exactly what they're about. So now's the time. Pause the video. All right, so I chose to go by halves on the x-axis, so skipping every other to be 1, 2, 3, 4, and 5, just to spread my data out. You could have clumped yours together. It'd be fine. Then to get all the way up to 20 ounces, I did have to go by 2s on my y-axis to ensure that I was able to get to that maximum value. Now, if we take a look at this graph, I haven't even drawn the line, but I want to talk about it. We should notice that there's quite a bit of a jump here compared to the distance between the other points. So what does that mean? That big of a gap. Must mean we got a heavy banana there, right? Because we're only going up one banana, but the weight is jumping more than it did for the other increases in number of bananas. So let's go ahead, draw in that line of best fit. Okay, I'm going to show you the first line that I drew. If you take a look at this, I kind of hit 2, almost 3 points, but then there's 3 points below the line. So that might not be the best line of fit. So I'm going to go ahead and erase that and draw in a better one. All right, that one seems a little bit more reasonable. I have 3 points on the line, 2 above, 1 below. So it's almost split up evenly, pretty close. So now I've got to write an equation for this. And again, your line might look slightly different. That's okay. Y is equal to my slope. So I got to pick 2 points on the line. I'm going to go ahead and pick this point here and then 0, 0, since I know it crosses through 0, 0, and look at those slopes. I am going up 12 and to the right 3. So my slope would be 12 over 3. But I can reduce that, right? And that reduces to 4 over 1. That's our slope, so 4 over 1x. Plus the y-intercept, where are we crossing? We're crossing at 0, which makes sense, right? Because if you don't have any bananas, that don't weigh anything. So y equals 4 over 1x plus 0. Do we need to have that plus 0? Nope. It's implied. We can leave our equation as simple as y equals 4 over 1x or just y equals 4x. Either way. But now let's do this for part D. Since you might have clumped your x values together and you might be able to fit 10 on your graph and look for 10. But I didn't. So to figure out how much 10 bananas weigh, I'm going to use that equation. Y is equal to 4 over 1 or just 4 times 10 because bananas is the x value. So 4 times 10 is 40. So I would guess 10 bananas weigh 40 ounces. Now I know this doesn't ask for this, but I kind of want to make a point. In our equation, y equals 4 over 1x, what does the slope mean? What does 4 over 1 mean? Think about it. Did you get it? 4 ounces per 1 banana. So that means on average, a banana weighs 4 ounces. All right, you're up again. Pause the video here. Try to go through this whole example. All right, so that's approximately my line of best fit. I know, just pretend it's straight. And we can see that we are going down about 4 units and to the right about 2. I'm going to write that over here. So if you look at, and maybe you did a different scale, but my x scale is going up by 1s. 1, 2, 3, 4, 5, all the way up to 10. And then my y scale is going by 2s because I had to get up to 20 for that depth. So using those scales, I am going down 4 and to the right 2. So that's going to be my slope. So y is equal to negative 4 over 2. But wait a minute, negative 4 over 2 reduces, so we should always reduce when we can. That would be negative 2 over 1x. Plus the y-intercept, we can see it's crossing that y-axis at 20. So there's my equation. All right, so for part C, it says interpret the slope and the y-intercept. Hopefully you remember from the beginning of the year, I had you guys interpret the slope and the y-intercept when we were studying linear equations. Now, interpreting the slope, what does that mean? What does negative 2 over 1 mean? It means that the depth is going down 2 feet, right, because that's our y, 2 feet per every 1 month. So the depth is dropping by 2 feet every month. So that means the river that we're talking about is getting shallow, right? Because the water is not as deep. Now it says predict the depth in month 9. So using our equation, months is our x value, so we would have y is equal to negative 2 over 1, or just negative 2, times 9 plus 20. Well, negative 2 times 9 is negative 18. Negative 18 plus 20, we would predict that our depth is 2 feet. And if we take a look at our graph over here, go over to 9, we can see that our equation or our line does cross there at 2 feet. So that's what we would predict for month 9. All right, you got it. Go again. Last example that I'm going to have you do. All right, so my line, I have 3 dots below the line, 2 dots above the line, and it appears to be about 2 dots right on the line, or very close. So when I chose my slope here, I picked this point and 0, 0, because I was able to see that these two fall perfectly on an x and a y value, which was 1,004. So I'm going up 1,000 over 4. Well, that reduces to 250 over 1. So then my slope is 250 over 1. And then my y-intercept, I'm crossing down here at 0, 0 at the origin, so it's plus 0. But like we said before, we do not have to write plus 0 if you don't want to. It's totally up to you. It's fine, but the simplest version would just be y equals 250x. Now for C, we got to interpret the slope. So what does 250 over 1 mean? 250 what? 250 people, right? That's the attendance. 250 people per 1 year. So each year we're saying the attendance is going up about 250. Now we got to interpret that y-intercept. What does that mean? What does 0, 0 mean? That's where it's crossing at. At year 0, we have 0 people attending. That's what our y-intercept means. 0 people attending. Okay, now the last question, predict the number of people who will attend the festival in year 10. Well, if I substitute 10 in there, that would be y equals 250 times 10, which, mental math, right? We got that, is 2,500 people. Now, in years past, kids have said to me, well, Miss Craig, that doesn't make sense. If 8 was 2,400, then shouldn't 10 be higher? And I don't disagree with you there, if that's what you were thinking. But using the model that we drew, this fits our model. Now, let's use our own logical thinking and interpret this with our own experiences that we've had. We can see that the jump here was only up 80. But whoa, check out the jump from year 7 to year 8. We went up 650 people. So maybe this particular festival has gotten really popular, so it might grow even faster. We have other sorts of models for that, but for right now, we're going to stick with this linear model and just use it as a loose approximation. Okay, but are you guys wondering how you don't necessarily always draw the same line or have the same equation of the line as I do? That's because we are just using a ruler or a straight edge and using our own interpretation of the graph to approximate this. So it's not exact. However, there are technology tools such as graphing calculators, Desmos, that can help us give us a single line of best fit. So instead of us trying to guess what it is, we could graph this table on Desmos, and then they would come up with, the technology would come up with, a line that is the best fit, that approximates the same distance for all the points above the line, the same distance for all the points below the line, and that it splits that exactly. And then what they talk about is a correlation coefficient. So it means what kind of association does this data have? But for the sake of our class, we're not going to get into this. You will get more into doing that on Desmos and with a graphing calculator in Algebra 1. But for now, I just want to make sure that we are able to find it by hand and use that information to predict results that don't necessarily show up in our table and on our graph. All right, that's a wrap for lesson 9.2. So you can go ahead and do the homework for this lesson.